Okay, plan tonight, guys, is hopefully nice wee relaxed session. All right, it's not too heavy, this stuff. Okay, so we're going to be looking at arcs and sectors, so working with circles. Okay, so we'll just go over some of the common words that we need to know. Okay, things that will come up, go over the equations we need to know and a couple of examples. Okay, circles in general, quite nice questions when we get them in the exam. Once you just take a wee step back and let it sink in a wee bit, sometimes on the first glance it'll be quite tricky. Okay, what it's asking you, just slowly break it down and it should become apparent. Okay, so that will make a wee bit more sense when we start going through some examples. Okay. Further to that, we'll go through a wee bit of how we work with equations, okay, because we need to rearrange. So quite a lot of questions in circles will ask you to rearrange that sort of equation. So we'll look at that, okay, and we'll go over and we'll just break down different forms of equations and go through the order at which we want to do that in, okay, and it's a pretty well defined order, okay, so well defined, nice and clean, and we'll just tidy that up. Okay, so we'll spend a bit of time doing that. It's pretty important going forward that we've got that knowledge. Okay, so we'll take a wee bit of time in that. The last part of tonight, we'll go over gradient. Okay, so we'll start looking at straight lines, start introducing that. Okay, start working with graphs. Okay, so our x and y's and things like that. And look at effectively looking at how steep lines are. Okay, so hopefully we'll get to that point tonight, and that will actually finish off Unit 1 quite nicely. So you probably, when I've been speaking through that, you'll probably have seen some of those questions coming up in those handouts I gave you. Okay, so those handouts I gave you a few weeks ago, especially the arcs question. Okay, so they were quite prominent in those. So after tonight, go back and look at those handouts and just work through those questions. You've got the solutions now. I sent that out in the email this week. Okay, send that out in an email this week. Just going through the solutions for each of those handouts. If there's any questions on those handouts, if there are any questions at all in Unit 1, give me a shout earlier, you let me know. Okay, the sooner we can go through it and we can have a look at it. Okay, guys? Super. Okay, is there any questions before we start on any part of it? Good to go. Nice one. Someone's just joining, coming in the room. So just let them in. Superb. Right, I'll just let that connect. And then I'll crack on. Okay, so hopefully I don't need to keep you 3 hours tonight. Hopefully. Okay. What's happening with that audio there? Okay, let's crack on. Right, let's get this shared. That's not what I wanted. That's what I wanted. Nice one. Okay, so I should be sharing that screen, guys. Okay. Nice one. Any questions, flag them up, put them in the chat. Okay, should pop up on my screen and we'll go from there. Okay, so as I said, guys, we're working with circles today and we'll be working with sectors. Okay, so just going to go through some common terminology that we use with circles. Make sure that's clear in our head. Okay, what the equations that we use aren't a big step from really common equations that we use for circumference, okay, and the area of a circle. Okay, so pi d and pi r squared. So it's really just a wee step forward from that. But let's have a wee look. Okay, so let's just draw a nice circle there. Okay. So I think first couple of things in a circle, and I'll just start right from the start. When we are talking about circumference, what we're talking about, okay, we're talking about the outside of that circle. Okay, so that's going to be a length. Okay, so you're either going to see that in centimetres, you're going to see that in metres, you're going to see it spelt a little better than that and written out a little better than that. Okay, but that's the circumference, the outside edge of it. Okay, a lot of times in the questions, it will ask you for the perimeter of shapes. Okay, so a lot of times when you see questions set around what we're going to do tonight, it will ask you for the perimeter. The perimeter will be the whole shape as well, so it might take into account straight lines coming off that. That will make a wee bit more sense when we start sort of breaking down into these questions, okay? But when we're looking at a circle, just a circle, the circumference, we're thinking about looking at the outside of that. Okay, so that's going to be a length. So that's going to come in metres, centimetres, very rarely, but it might come in millimetres. Okay, very, very rarely will come in kilometres. Okay, but that's not unheard of. So circumference, just that outside edge. Okay, diameter, hopefully that's a nice straight line. Diameter is a straight line from one edge to the other. And very importantly, it goes through the middle of that circle. Okay, so the diameter of that circle, okay, has to go through the centre of it. Okay, and that's really, really important. Okay, so it goes from one edge to the other and it goes through the centre. Okay, so we're not going to cover it tonight, but when that line, there's a straight line from one edge to the other on a circle. Okay, but it doesn't go through the centre. That's called something else. That's called a chord. Okay, so we're not going to cover that tonight. We cover that later on in the course when we come back to this. Okay, but the diameter is one edge to the other and it goes through the centre. Okay, so we've heard of that term before. Okay, okay, from the centre of the circle to the outside edge, radius. Okay, so pretty confident you'll be comfortable with that. Okay, so circumference, diameter, radius. Okay, when we're talking about the degrees in a circle, when we're talking about angles in a circle, okay, a full rotation is going to be 360 degrees. Okay, now that will be important when we start breaking circles down. Okay, so 360 degrees in a full circle. Okay, so if we start at this point, go all the way around the circumference, we're going to travel 360 degrees. Okay. So that's pretty common knowledge. Okay, that should be pretty comfortable with you. If not, again, go back to National 4 and BBC Bite Size, have a wee look at circles there. Okay, and it'll talk you through, start right at the beginning and go through it. Okay. What we are interested in is taking common equations, okay, that you might see at sort of National 4 level. Okay, so the circumference is going to be something called pi times the diameter. Okay, you can put a wee times in there if you want. Often you won't see it with that times sign in it. Okay, so it's pi times the diameter. Okay, so what is pi? Okay. Pi, well, the actual symbol is just a Greek letter. Okay, what does it stand for? It stands for the number 3.14, recurring, or not recurring. Okay, it doesn't recur, that's the opposite. Okay, so it stands for 3.14, so the number pi is 3.14. So instead of writing 3.14 in the equation every time, we use the letter pi in maths just to make it a wee bit neater. Okay, This is one of, there's a few letters, okay, used in math, used in engineering, that we know will refer to something. Okay, and pi is one of those letters. Okay, so it's just a Greek letter. It's just like is using X, using Y. Okay, what we substitute in for it is 3.14. Okay, so if you did pi in your calculator, of which I don't actually have, which is terrible. Give me 2 seconds, bring up bloody calculator. Just came in now. Hey Sandra. Okay, give me 2 seconds, guys. I'll just go and get a calculator. Okay, so if you type pi into your calculator, okay, she's usually down the bottom beside the answer button. You usually have to press shift to get it. Okay, and you press equals. It should give you the number and write it out fully. Okay, it's like 3.14159, blah 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 blah. Okay, so that will continue on loads and loads. So that's why we don't actually write that number out physically every time we do an equation, and we use the letter pi, the Greek letter pi, to substitute that in. Okay, so that pi, whenever you see it, will always be used in place of 3.14. Okay, when you do a calculation on your calculator, use that letter pi. Okay, we need to know it's 3.14 for the non-calculator papers, but often in the non-calculator papers it will actually tell you that. Okay, so refer to pi as 3.14. Okay, in the calculator papers, using our calculators, we actually put in pi. Okay, and that will be a wee bit longer. Oof. Okay, so that's all pi is. Don't be intimidated by pi. Okay, big fan of it. Oh, pardon me. So circumference is pi times d. Okay, the area of a circle is pi times radius squared. Okay, so pi r squared. So again, that 3.14 continues. Okay, that 3.14 gets substituted in place for that pi. Then we're doing the radius squared. So nice easy equations you've seen before. Okay, familiar with them. We're going to add a wee bit to that. Okay, and we're going to consider cutting that circle up. Okay, and how we work that out. Okay, so we're going to consider if we do a sector like that. Okay, and how we would find out either the area inside that sector or potentially the perimeter, the outside of that sector. Okay, or it could be even the big one. Okay, if we get given the bigger area, how we would work out that bigger area, or the length of the outside of that area. Okay, so that's what we're going to consider tonight. Looks like a bizarre American flag. Okay, so we're going to take those two equations that hopefully we've seen before, we're familiar with. Okay, and we're going to consider if we cut a slice out of that. So effectively just cutting slices out of that, like slices of pizza. Okay, and take that out. The thing we're going to add in, okay, and we're just going to take, effectively, it's a ratio of that. Okay, so if we were doing the circumference, say, okay, and we only wanted to find a portion of that, okay, we're going to call that an arc. Okay, and we're going to find the arc length. And we're still going to use that pi d part of it. So we're still going to do the pi times diameter, okay? But what you need to add in is the angle, which will be the angle in here, okay, divided by 360. Okay, and why do we divide by 360? Well, that's how many degrees are in a full circle. Okay, it's as simple as that. So essentially, that part is just a ratio of how much of the pizza, how much of that circle you're taking away. Okay, a ratio, a percentage of how much of that circle you're taking up. Okay, so let's put some numbers into that. Okay, if we had that circle here, and we say that angle's 60 degrees. Okay, so we say that angle in there's 60 degrees. Okay, and we say the diameter of that circle is 10 centimeters. Okay, in fact, let's write that out a wee bit neater so you've got that. Okay, I was just going to do that quickly there, but I'll write it out a wee bit neater so it's there. Okay, so we've got a full circle there. Centre of that circle, and then we've got a sector in here and an angle. Okay, we want to find out the length of that part of the circumference. Okay, so we're going to call that an arc. Okay, so we want to find out the length of that circle. So calculate the length of that arc. Okay, so that arc length would equal that angle divided by 360 divided by pi d. So if we say that angle, I don't know why we're saying that. We say that angle equals 60 degrees. Okay, so that wee circle above the 0 there, that's just a degrees sign. Okay, so that's just essentially, it's, instead of writing out its units, okay, that's what we use to indicate degrees. Okay, angle is 60 degrees. We'll do diameter of 10 centimeters. Okay, we're just putting that in to the calculation. Nope. And then we'll use our calculator. 60 divided by 360. Right now. 5.2. Okay, so that green line. Sorry, someone's just joining us there. That green line, okay, is going to be 5.24 centimeters long. Okay, is everyone getting that in their calculator? Okay, is everyone putting that in their calculator and that's coming out okay? So everyone's comfortable with pi, everyone's comfortable with putting that fraction in their calculator. Super. Okay, nice one. Okay, so we might get given that angle, 60 degrees. We might get asked to work out that small arc. Okay, we might also get asked to work out the big arc. Okay, the rest of that circumference. Don't be worried about that. Again, we just look at it. So if we get given that angle in there, 60 degrees, that means the rest of that from there all the way around is just going to be 360 minus 60. So it's going to be 300 degrees. Okay, then it's just a case of putting that in the calculation and working through that. Okay, so the large arc, same equation, angle over 360 times pi times our diameter. The diameter is the same, 10 centimeters. Okay, put in our 300 over 360 multiplied by pi multiplied by 10. use a calculator. Multiplied by pi, multiplied by 10. 6.2 centimeters. Okay, and how many decimal places and things like that I'll cover later on when we do, because they're sometimes quite specific in the question. So don't worry too much at this bit. I'm just going through the sort of equation and what we're looking at. We'll go through significant figures and we'll go through decimal points later on. Okay, so that's arc length. Okay, so we're going to call that small arc, that green line that we've got is 5.24. That's referred to as the minor arc. Okay, and the big one, the red one, okay, so the 300 degrees, we'll refer to that as a major arc. Okay, nice and simple, reasonable terminology, nothing illogical there. Okay, and it makes sense. Okay, so that's good. That's the outside. Okay, so that's the outside, that's working with the circumference, working with that pi d equation, and then finding that ratio. Okay. Similarly, we can look at the circle area. Okay, and can ask about the circle area. Okay, so if we've got a sector, let's do from the centre that, and we'll do from the centre like that. Oh, sorry about my terrible drawing, guys. Have an angle in there, and we'll call that angle, let's say it's 110 degrees. Okay, and say the diameter this time is 14 centimeters. Okay, so the equation for area of a circle, if we're doing the full circle, pi r squared, in the same way we did for finding out part of the circumference, we just add in that ratio aspect of it. Okay, so area, can't spell area, of sector. Okay, so when we take a slice, we call it a sector, equals the angle over 360 multiplied by pi multiplied by r squared. Okay. First thing we need to do, okay, nice and easy, find out what r is. Okay, r is just half of the diameter. So you could write out r equals d over 2, which equals 14 over 2, which equals 7 centimeters. So it's got a radius of 7 centimeters. Now, you don't get any marks for that. Okay, dividing 14 by 2, it'd be very, very generous if you got a mark for that. Okay, so don't expect. No, knowing 14 by 2 is going to be giving you 7. Okay, area sector, let's go through that. Okay, so we've got, try to find the area of this sector in here. Okay, 110, that angle, divided by 360, multiplied by pi, multiplied by r, which is 7, squared. Let's just keep it in the calculator right now. Okay, let's say 110 divided by 360 multiplied by pi multiplied by 7 squared. I'm getting 47.04 if you want to be. Okay, so it's in centimeters, it's an area, so it's going to be centimeters squared. Okay, so you do get marks for having the right units. Okay, so units are really, really important. Okay, so like when we were finding out areas of squares, rectangles, triangles, whatever it is, okay, if it's a 2D shape, it's to the power of 2, so centimeters squared. If it's a 3D shape, it's to the power of 3, so it'll be centimetres cubed. Okay, so just remember that. So when it's the area, centimetres squared. When it's the volume, centimetres cubed. Okay, nice one. So we've got the area of the sector, 110 degrees, 360, 47.04 centimetres squared. Okay, so nothing complex in your calculator there, it's nothing out to trick you. You might get asked, again, the area of the big sector. They tend to make it quite obvious in questions once you take a look at it and once you take a breath. And sometimes when you look at it, it's quite tricky. They've cut a wee shape out here or they've added a wee shape in. Okay, so when we look over some exam questions, that will make sense what I'm saying. But it's not too bad. I quite like these questions in the exam. Okay, so area of the bigger sector. Oh, just write area. Okay, same equation, 360 multiplied by pi multiplied by r squared. Okay, r doesn't change. The angle this time, okay, so the angle we're going to put in here, it's just going to be 360 minus the 110. Okay, so it's going to give us 250. Okay, so we're just putting 250 by 360 multiplied by pi multiplied by r squared. No bother at all. 250 divided by 360. Alright. I am getting 106.9 centimetres squared. Okay. Tonight, that's the only two equations given. Now, let's just write these equations down. Arc. My God, I couldn't remember the word arc. That's a bad sign. Okay, arc equals angle divided by 360 multiplied by pi multiplied by d. The area, or the sector, sorry, equals angle divided by 360 multiplied by pi multiplied by r squared. Okay, most important thing you take away tonight is these are not given in the exam paper. So you need to know them. Okay, these equations are not given in the exam paper. Okay, so you need to be aware of them. You need to really know how to use them. Okay, so let's think about it with a couple of examples and think about the angles and the ratios. Okay, so let's think about angles for a wee second. Okay, some of the words they might use to describe the angle. Okay, so look out for, find the acute angle or the area where the angle is acute or something along those lines. So what's an acute angle? Okay, that's just an angle from 0 to 89 degrees. Okay, a right angle, it's just 90 degrees. An obtuse is 91 to 180, and a reflex is 180 to 360. Okay, Okay, so just look out for those words. They might throw one in, throw one out. So just be aware. So that should be comfortable with that. You should have seen those words. Okay, maybe reflex, not so much. But certainly when you did triangles in maths or whatever, acute, right, and obtuse should pop out to you. Okay, that reflex one might jump out to you. So, for instance, that 250 degrees. Okay, that's the reflex angle, okay, because it's over 180 and it's below 360. Okay, so they might ask something in relative to the reflex angle and finding the sector area or finding the arc length. Okay, so just be aware of those terms. Okay. Let's think about the ratios themselves. So the angle divided by 360. Okay. Now, often they'll throw one of these questions into the non-calculator. Okay, and I think someone picked up on that when we were doing those handouts, and someone asked where do you start? Okay, so often it's what throws you off or what puts you off straight away with trying to answer it is doing something by divided by 360 multiplied by pi multiplied by another number. Okay, there's just too much going on there. So let's just start looking at that angle first and let's start breaking that down. And it's all about how we simplify that down. Okay, making it into a nice simple fraction for us that we can use. Okay, so trying to multiply 250 divided by 360 multiplied by 3.14 multiplied by 10 squared. Very, very difficult something to do. Okay, so let's start putting these into more easily digestible fractions. Okay, and these are the ones that I would expect you to know and to be aware of. Okay, and they won't throw anything outrageous at you. They might, but they probably won't. All right, they won't throw anything outrageous in the non-calculator paper, but they'll start with, what am I saying? Starting with probably 30 over 360. Okay, so let's start simplifying that down. Okay, 30 over 360 could be simplified down into 3 over 36. Okay, which could be simplified down into 1 into 12. Okay, and I think that's going to be the hardest one that you'd see. Okay, 30 over 360, so it's just simplifying that down into a wee bit more easily digestible. The 1/12 is more digestible than 30 over 360. Okay, so let's keep building up. It will usually be something that is divided, or you're able to divide by 30 or 45. Okay, so 45, why did I say that? Okay, 45 divided by 360. Simplified down to 1/8. Okay. There's no secret way to really find that out. It's just, if you see that, how many times did 45 go into 360? Okay, so you can even just write that out. 45 plus 45 is 90, plus 45 is 135, 5 is 180, okay, 225, 270, 315, 360. Okay.
So can you just write that down the side of your paper?
You could. Yeah, if you see something like that and it's 45 and you're like, well, that must go into 360 so I can simplify that down. Okay. 30 over 36 is quite nice because you can sort of take that 0 away and then look at it a wee bit more digestible. There's really no way to break 4 point. You don't want to simplify that anymore. It's really hard to simplify 45. So if you do 45, how many 45s go into 360? Okay, it does divide equally. Okay, it's a nice number, number 8. Okay, It's just a case of recognising that, how many 45s go into it. Okay, so there's 8 45s, so that simplifies down to 1/8. Okay, and then it's just a case of, I would expect it to be a multiple of 30 or 45. Okay, so if that's the case, let's go through the multiples of 30. Okay, so 30, you've got 60 over 360. Okay, which simplifies down to 1/6. Okay, so there's 6 60s and 360. Okay, a wee bit more digestible. Okay, you've got 90 divided by 360, simplifies down to 1/4, 1/4, 1/4, 1/4. Okay. 30 on top of that would be 120 over 360. Okay. And that would go down to 1/3. Okay. So then we can just take away the zeros and then look at what goes into 12 and what goes into 36. Okay, so that'll go down to 1/3. 150. Okay, starts getting a wee bit trickier because that's a wee bit more complicated fraction, if you like. Okay, so 150 divided by 360. Okay, let's make it a wee bit simpler for us. Let's take it down to 15 over 36. Now what goes into 15 and also goes into 36? Okay, so the biggest one will be the number 3. Okay, you might look at it, it's not 5, okay, because 5 doesn't go into 36. It's not 4. 4 goes into 36 but doesn't go into 15. Okay, it's 3. Okay, so there's nothing bigger than that goes into both of them. Okay, so you can sit and work that out, but there's nothing bigger than 3 that goes into both of them. It goes into that 5 times, and it goes into that 12 times. Okay, so slightly harder fraction, okay, but it's a lot easier to work with than 150 divided by 360. Okay, that'll be one of the trickier ones. 180 over 360 is a nice one. Okay, that would be a half. Okay, if you get that, you're laughing. Okay, plus 30 on top of that, you'd be into 10. Okay, simplify that down a wee bit. What goes into 21? It goes into 36. Okay, 10 doesn't, 9 doesn't, 8 doesn't, 7 goes into 21. Does 7 go into 36? No. Okay, 6 goes into 36 but not 21. 5 doesn't, 4 doesn't, 3 does again. Okay, so 3 goes into 21 quite nicely, 3 goes into 36. So again, it's 7 over 12. Okay, so you can see the most complicated ones when it's a multiple of 30 is going to be something over 12. Okay, 210, so what would be 30 over that? So 20 to 40 over 360. Okay, that's a wee bit nicer again. Take off the zeros, 24 over 36. 12 goes into both of them, so you're getting 2/3. Okay, so you can see how it sort of fluctuates, but you need to be able to recognise that. We might as well keep going. 270 over 360. What goes into 27 and 36? Okay, 9. So 9 goes into that 3 times, 9 goes into that 4 times. Okay, so 3/4. Okay. Now you might notice first that 3 goes into both of them, so you could probably maybe do that. It would be 9 over 12. Okay, and then you'll see, okay, I can simplify that down a wee bit further. Okay, so don't be worried about taking big jumps. Take small jumps, just simplify it down, take your time, simplify that down to something more digestible. Okay, 3/4 plus 30, 300 over 360. Okay, so take away the zeros with 30 over 360, over 36, sorry. 3 goes into that 10 times, 3 goes into that 12 times. Can that be simplified any more? Yes, it actually can. That can be simplified down to 5/6. Okay. And then you've got 330 over 360, which will give you 11 over 12. Okay, as simple as that can be. Okay, so bunch of fractions there, bunch of things that maybe not expect you to know off the top of your head, but expect you to recognise in a non-calculator. Okay, so that is more than likely that something like this could come up in non-calculator. Okay, so we'll use some of these and we'll look at some of these examples and we'll go through them, so don't worry too much. Let's go back up to 45. Wow, look at that. Okay, if anyone's not copied that, give me a wee shout, or not recognise anything, give me a wee shout and we can look over it again. Okay, likewise 45 is a nice multiple of 360. Okay, so 45, 90 over 360 we've already done. Okay, that was also a multiple of 30. Okay, then you could see something like 135 over 360. That looks quite a toughie. Okay, let's not get around it. Okay, but think straight off the bat, well, 45 might go into this. Okay, so we know 45 goes into 368 times. Does 45 go into 135? Yes, it does. It goes in 3 times, so it's 3 over 8. Okay. That's a wee bit of a more difficult one to recognise. Okay, the multiples of 45 are a wee bit more sketchy. Okay, but 3 over 8 is still a wee bit more digestible for us to use in a non-calculator. Okay, so 135 divided by 360, 3 over 8. Oh, getting ahead of myself. 135 plus 45 is 180 over 360 equals a half. Um, 45 on top of that's 225. Okay, again, that looks like another tricky one. Okay, again, I need you to be able to recognise that 45 is going to that. Okay, so it's going to be 5/8. Okay, don't be scared to take that to one side and just go, right, I know 45 is used commonly, so let's think about that. It's obviously not 30. 30 is not going to go into that. Okay, so think about it in a wee bit logically. 45 is a nice way to divide up by 3, to divide 360 up. How many times does 45 go into that? 45 plus 45 is 90. Plus 45 is 135. Plus 45 is 180. Plus 45 is 225. Okay, 1, 2, 3, 4, 5. Okay, 5/8. Okay, that really, if you're unsure in the slightest, double check with yourself. Okay, don't be scared. You're not going to lose marks by writing that out. You're not going to gain marks, but you're not going to lose marks. Okay, getting this right is the most important. Okay, so 225 plus 45 is 270 over 360. Okay, so 27 over 36. So 9 goes into both of them, so that's 3 over 4. Okay, so some of these numbers come in both of the multiples, so you'll see them coming up. 315 over 360 to multiple of 45. Okay, and that's going to be 7/8. And then you've got 360. And that's 1. They're not going to give you 360 over 360. Because that's just a full circle. Okay, so went through some of them quite quickly, so if it doesn't make sense, if it doesn't jump out to you, okay, just take a wee second and let that digest a wee bit. Okay, so this is how we use those in non-calculator. It's been able to recognise we can simplify that down into something that is digestible, something that we can use. Okay, so let's say we were given an angle of 120. Okay, that angle in there. (120 degrees). Okay, so imagine this is in a non-calculator. They'll give you pi equals 3.14. Okay, so you've seen earlier when you typed in pi in the calculator and you pressed equal, okay, that number continues on. They'll simplify that for you and put it to 2 decimal points and give you pi equals 3.14. Okay, and let's pick a diameter of 10. Okay, and let's say we want the minor arc, so that's a small arc, so that's that. Okay, so that's the information you're given. Find the minor arc. Okay, so we want to put that in our calculation. So let's just work through that. So arc is equal to the angle over 360 multiplied by pi multiplied by the diameter. Okay, let's substitute stuff in. 120 over 360 multiplied by 3.14 multiplied by the diameter, which is 10. Simplify that down. Okay, so simplify that down. You can even take that over to one side and do it over here. Okay, 120 divided by 360 equals 12 over 36. Can I simplify that any further? Yep. Okay, 12 goes into that once, into that 3 times. So it's going to be 1/3. Happy with that. Okay. Now that is a lot more digestible than 120 divided by 360 multiplied by 3.14 multiplied by 10. Okay. And now it's a case of just working through it. It's not the easiest sum in the world. Okay. That's live. Okay, so 1/3. Oh, sorry. Do this part first. Okay. Okay, so 31.4 divided by 3. Okay, so we know there's 10 going into it. 10.14. Oh my god, can I think? 3 10.4-ish. Okay. .46. So, try to do it in my head. Okay. This part here, okay, this dividing part, okay. Look back at National 4 stuff and it will talk you through the dividing, the long division type aspect of it. Okay, and it'll walk you through that. Okay. I'll make it nice and simple. Probably wasn't the best example, but I'll make it nice and simple. Okay, so it's all about simplifying that fraction down, and then after that it's really just about practice. Alright, so there's quite a few examples in that. Let's have a wee look at another one. So we look at another one. Sorry, I'm distracted. Any questions on that? Sorry, before I move on. No. Okay, this one. Let's have a wee look. This is the actual question. I was just getting distracted. This is the actual question that was asked about when we were talking about this. And I said we'll cover it when we do this. Okay, so let's cover it. Okay, so it's actually the same angle, bizarrely, it's given. Which caught me a wee bit off guard. And the question looks like gives you this angle instead. Okay. Okay, and in the question, this bit's cut out completely, and you'll see that quite often. There'll be a circle with a section cut out. Okay, so it's just that sort of large section. Okay, and it asks for the major arc. Okay, and it gives the angle is 240 degrees. Okay, and it gives you the radius 30 centimeters, and it asks, oh no, sorry, and it gives you pi, a very badly drawn pi. It gives you pi equals 3.14. Okay, so there's no units to pi. Don't know if I said that, so don't be caught out by that. It's sort of unitless. Okay, so that's what you're given in the question. So what I'll find the question after and we'll have a wee look at it, the picture. Okay, so we're given that, and we are expected to know arc equals angle over 360 multiplied by pi multiplied by diameter. So don't get caught out by this trick, this devious trick where they give you the radius. Okay, we know that the radius is just, the diameter is just 2 times the radius. So diameter is just 2 times 30, so diameter is 60 centimeters. Okay, so let's substitute that in. Okay, so we've got an angle of 240 over 360 multiplied by pi, which is 3.14, multiplied by a diameter of 60. Okay, take this to one side, let's tidy that up. Okay, 240 divided by 360. Take away the zeros, 24 over 36. Okay, what goes into 24 and goes into 36? Okay, an obvious one's going to be 12, so it's going to be 2/3. Okay, we can put that back in. Okay, so the next bit, this is what sort of distracted me earlier. Okay, the next bit, we actually do quite an interesting thing. So we'll cover this later on when we look at the order in which we do calculations. Okay, so when we've got an equation, we'll look at the order. When do we multiply? When do we divide? When do we add? When do we subtract? When do we repel? Okay, we're usually quite good at it, but just wanted to really nail that down. Okay, so we'll look at this a wee bit later on as well. Okay, but essentially what you do here is we can take this and multiply them together and then leave the 3.14 to the end. Okay, that's a wee bit more digestible because 2 divided by 3 multiplied by 60 multiplied by 3.14. We've just changed the order of that because they're all multiplying together, so we can do that. Okay, this is just a wee bit more digestible than trying to do 3 divided by 60 times 3.14. So it's all about breaking things down into more digestible chunks, is what I'm trying to say. Poorly. In fact, that's where BBC Bite Size get their name. Okay, breaking it down into more digestible chunks. Okay, so if we do 2/3 of 60, okay, so 60 divided by 3 is 20, multiplied by 2 is 40. Okay, so 2/3 of 60 is 40. And then we've got a straight calculation, times 3.14. Okay, now you could give that a bash and do long multiplication, or what they actually do is they actually put another step in where they break this down into 10 multiplied by 4 multiplied by 3.14. And that actually caught me out as well. Okay, I probably wouldn't have thought about that in exam conditions, but that's what the sort of answer breaks down. Okay. Now, why that's interesting, it's a more easily digestible long multiplication when we do it out. Okay, so we can multiply the 3.14 by the 10 first. Okay, and just have 4 multiplied by 31.4. Okay, so people have different ways of doing multiplication. They've got different ways of doing division. Okay, so it's what you're comfortable with and what you learned. Okay, so even 5 years ago, would have done it differently. 10 years ago, you would have done it differently, and whatever. Okay, so lots of different ways to do this, so that's why I'm not going too much into this. Okay, this is sort of the way I did it. Okay, so decimal point stays where it is. 4 times 4 is 16, carry the 1. 4, 5, so there's nothing to carry, and that's 12. Okay. Now, that seems like I've been quite jumpy and I've been quite sporadic with what I was doing and how I approached it. Okay. Essentially, I'm trying to find the easiest way to get to the end point. Okay. Some people would have been able to do 40 multiplied by 3.14, but depends how you got told to long multiply. That's quite a difficult multiplication. Okay. This is why it advises this stage. So 40 can be broken down into 10 times 4. It makes sense when you look at that. All right. When I first looked at that written down, I was like, oh, that actually did catch me out a wee bit. Okay, but that's what it's looking for, you to break things down in sensible ways and logical ways, in mathematically correct ways, okay, but in logical ways. Okay. that will come with a wee bit of practice, okay? This, knowing when to simplify and what it simplifies down to, will come with a wee bit of practice and looking at a couple of examples, okay? So it looks horrible, but it's actually quite a nice, if you've got the time to do it, it's quite a nice question in the non-calculator, okay? They don't often try and catch you out by putting outrageous numbers in it, okay? The most difficult bit is usually multiplying this 3.14 because that decimal throws a lot of people off. Okay. What I would say with that is if you find anything in the non-calculator that uses this and you don't know how to approach it or don't know how to break it down, come to us and we'll do it as a group. All right, it's good to look at it as a group and then we'll just share that. We'll break it down, we'll go through it and then we'll have that in the sort of bank. Okay, so there's a couple of things just to look out for there. Let me do a couple of examples. Yeah, I'll do a couple of examples and then we'll have a wee break. In fact, that's 7:10. Let me do one more example of an arc where it's going to be a calculator paper, so we can just use it in our calculators. I'll do one more example of an area, then we'll have a break and I'll give you the pages where you can find these questions. Now the questions might catch you a wee bit off guard, but just slowly take it and think it through, okay, because sometimes they throw cutouts of shapes and sometimes they'll throw something else in. Okay, so let me go through one more example of each. We'll be having a break by past, I promise, okay? So both of these will be in the calculator side of it. Okay, let's have a circle like so. Let's have a cutout. So this is cut something out. Okay, so in the question, this doesn't exist. Okay, so it looks like a pizza with a slice out it. They give you this angle, 320 degrees. But they've written it like this, okay? They've labelled different points. So they've labelled this as A, this point is A, they've labelled this point as B, and they've labelled this point as C, and they've written it like this, angle A, B, C equals 40. Okay, so that makes sense. So what they're trying to say by that is that angle in there, that angle in there is 40 degrees. And they write it ABC, B is the point of that angle. Okay, so A is one of the outsides, B is going to be the point of that angle, and C is the other outside. So it's a path. So it goes path A, B, C. Now they can label that with different letters. They can label it with D, E, F, but 99% out of 1,000, no, 99% out of 1,000, it makes sense. 99 times out of 100, no, in fact, 100 times out of 100, the letters will be in order. Okay, they might just try and throw you off for whatever reason. Okay, ABC is the normal one. Okay, D, E, F, you'll see F, G, H, whatever. Okay, so A, B, C, the middle letter is the point of the angle. Okay, and so if they put ABC equals 40 degrees, that angle in there that I've indicated is going to be 40 degrees. Okay, we know the full circle is 360 degrees, so that big angle is 360 minus 40, so it's 320 degrees. Okay, so silly little things like that, just don't let them catch you out. Okay, so they asked for the major arc. So the major arc is the big arc, so it's all the way from A to C. Okay, that outside part. Okay. What do they give you? They give you the radius. And the radius is 7.4 centimeters. Okay, so straight away, diameter, just double the radius, 14.8. Okay. Happy with that. So that's as much information as we need to get this done. Okay, so we're looking for the major arc. Okay, so arc equals angle over 360 multiplied by pi multiplied by d, diameter. 320 was the angle for the major. 360 pi multiplied by diameter, which is 14.8. Okay, put that in your calculator. 320 multiplied by pi multiplied by 14.8. Jeez, oh, forgot to divide it by 360. That's a wee bit more reasonable. Okay, 41.3 centimetres I'm getting. Okay, let me know if you're not seeing that. Okay, 41.3 centimetres. Okay. In fact, do you know why I use that as an example? Because that's one of the questions that I asked for the work out the reflex angle. Okay, so they use the word reflex in this, so you should know that you're finding the major arc. Okay, so they give you the 40 degrees, that then ask you for the reflex. All right, so just be aware of that. Okay, so that reflex angle is something between 180 and 360. So it's asking for that big angle. If it asked you for the acute angle, you'd go for the 40 degrees. Okay, so that's just watch out for that terminology when they throw it into a question. All right, they sometimes don't make it obvious. Okay. Said an example of the area, didn't I? Do you know what that is? That's when they ask you an area and you have to rearrange it. So I'll cover that after the break. Okay, so this is a good one. This is a common one. Okay, so this is when they give you, I'll try my best to draw this. A shape like this. Okay, and then they'll have a bit cut out like that. Okay, and they'll give you the distance from here to here. Okay, in this case it's 9 centimeters. Okay, and they'll give you the distance from here to here. It's 15 centimeters. Okay, this area in here is cut out. Okay, that's an angle. The angle in this case is 105 degrees. Okay, do my best to copy this down. Okay, so that red shaded area is cut out. The blue shaded area is the shape that we want to find the area of. Okay. So the question would be along the lines of find the blue area. Okay, that wouldn't be the question, but it would give you a shape and say find the area of the shaded part. Okay, so the shaded part we're finding is that blue area. Okay, so we're using the area equation. So area equals angle over 360 multiplied by pi r squared. Okay, but then we're removing that wee red area as well. So we need to find the area of that red area, take it away from the total. Okay, so the total area, okay, so the radius is going to be 15 centimeters. Okay, so area total equals angle over 360 multiplied by pi multiplied by r squared. Okay, so it's going to be 105 over 360 multiplied by pi multiplied by 15 squared. So we're looking for the total blue plus red. Okay, so putting that in a calculator, 105 divided by 360 multiplied by pi multiplied by 15 squared. It's going to be, I'm getting 206.2 centimeters squared. Yep. Okay. So the question is find the area of the blue. So I'm going to do that total area minus the red area. Okay, so I want to find the area of the red part and take that away from the total, and that will leave me with the blue area. Okay, so find the area of the red. We are same angle, 105 multiplied by pi multiplied by r squared. R in this case is 9. Whacking that in the calculator. Got 74.2 centimeters squared. Okay. So area blue equals area total minus area red. We'll lose anyone, give me a wee shout. Okay, area total is 206.2 minus area red, which is 74.2. Okay, 206.2 minus 74.2, 132 centimeters squared. Okay, so that's the area of the blue area. Okay, that shape's quite common. Okay, you may see things like that. Okay. Okay, let's have a wee break and then give this a wee go. Okay, I've got written down page 39 to 46. Okay, page 39. So this is the booklet in middle. Okay, so the Unit 1 booklet that we've been working with. 39. Okay, nothing too bad there. 1 decimal point. Okay, that's weird. I'm guessing question 2, calculate the perimeter of each. Oh yeah, sorry, it says that. Right. Calculate the perimeter of each section, question 1, so that's fine. Find the length of the minor. Find the length of the major. Okay, so I see both of them. What's this saying? Calculate the sector. So that's just additional questions on that. Calculate the area of the circle. Okay, so there's nothing, 39 and 40, there's nothing that you shouldn't be able to do. We move into exam questions on page 41. Okay, and most of these we should be able to do it. There's a couple that jumped out at me. Okay, perimeter, no problem at all. That's a wee bit trickier, this door one. Okay, but we should be able to do that. Okay, so just think about that one, have a wee read of it. Okay, that's not a problem. This, question 4, calculate the perimeter logo. Okay, so you should be able to do this. Okay, so this is one of those ones that's quite tricky. you're calculating the perimeter of the logo, so the outside edge all the way around it. Okay, so have a wee think about that one. Question 4 is probably something I would expect, that sort of format, that sort of difficulty. So sensor security covers blah blah blah. Calculate the area. Well, that's nice and easy. This one jumped out at me. I don't think we've got the knowledge yet to do 6. Okay, so just take a wee note of question 6. I don't think we should be able to do that because we've not covered how we would find the area of this wee triangle yet. Okay, so avoid question 6. Question 7 is a toughie. Okay, so have a good think of question 7 and the way you would approach that. Okay, that came up. It's not nice, but it's not too bad when you think about it. Okay, so have a wee look at that. Those wee squares mean right angle. Okay, so when that indicates like that, so that angle ADC, that wee square in there means that's a right angle, so it's 90 degrees. Okay, so that 90 degrees, that's 90 degrees. That's essentially, that's just a sector. Okay, so that's just a cutout of it. Okay, so have a wee think about question 7. Avoid question 6, have a think about question 7. I think avoid question 8, because we've not done that yet. This is the one I just did. Interestingly, I actually did it the wrong way around. So have a go at it when it's written out correctly. Okay, question 9. Okay, so I ask you for the area and the perimeter, so we go at that. Area of the shaded sector. Right, avoid 10 and 11. Right, that should be enough. Let's not take it too far. Okay. So have a wee 20-minute break. Have a go at a couple of questions on page 39 and 40 just to get you in the groove of it. And then have a go at 1, 2, 3, 4, 5, not 6, 7 and 9. So not 6 and 8 and just stop at 9. Okay, so 1 to 9, avoid 6 and 8. Happy with that? Nice one. Right, let's say a 20-minute break, which will take us to 1:45, and then take 20 minutes trying them out. So get as far as you can. Don't worry if you don't finish everything I've just said there. Get as far as you can in those 20 minutes. Okay, so take 20 minutes, go and get some fresh air, then take another 20 minutes. So that'll be 45. So we'll come back together at 8:05. Okay, come back together at 8:05 and we'll move on a wee bit. Okay, any questions, give me a wee shout. I'll go away from my desk for a wee bit, but I should be about. Okay. Okay, so the last thing on this sort of arc sector type stuff, I just want to go through, or just want to go over again, I suppose. It's stuff that you know, but let's just go over so we're really sure of it. Okay, is this fact that we sometimes have to rearrange it. Okay, so it doesn't always ask find the arc length or find the sector area. Okay, it sometimes says here's the area, here's the radius, what is the angle? Okay, and that means we need to rearrange that equation. Or here's the arc length, here's the angle, what's the diameter? And again, we need to rearrange all that equation. So I just want to go over again, I know you did BIDMAS in the first couple of weeks. Okay, so BIDMAS is an important part of that. BIDMAS is about the order we do certain operations. Okay, so we do brackets, indices, division, multiplication, add, subtract. Okay, that's the order we do, or we work with a sum. Okay, so let's just really make sure we've got that down. Let's look at how an equation balances out. Okay, and that word balance is really important. Let's see how that equation balances out. and then see how we can use BIDMAS, okay, as a sort of structure to rearrange equations. Okay, so we use that same idea, we use that same concept, we can write out BIDMAS, and we can work with that to rearrange an equation as well. So let's just take a wee bit of time on that, okay, and share my screen. And just make sure we're comfortable with that. Super. Right. Wrong button. Okay. BIDMAS. Or BODMAS. Same thing. Okay. Same thing. Just two different words. That I and O changes around. One means index, one means orders. Effectively, that's just your squares. Okay, so brackets, indices, divide. Well, all right, on this first. Multiplications, add and subtract. Okay, what I would say there is when you've got both multiples, multiplications and divide, we've seen enough now that you can do that in any order. So you can manipulate it to do a multiplication before a divide or a divide before a multiplication. Okay, so just be comfortable and aware of that. Likewise, if we've got an add and a subtract in an equation, okay, it doesn't matter if we do the subtract first or we do the add first. Okay, it works out to be the same thing. Okay, so just be aware of that. Sometimes doing it one way will be easier. Okay, and that was the case when we were doing that last example. Okay, when we did 2/3 of 60 instead of 2/3 of 60 times 3.14. Okay, just by doing it in the correct way, again breaking it down slightly, it made our life a wee bit easier. Okay, so let's just have a wee look at some equations. So I think this was covered in the first week or so. So I'm not going to too many, but say something along the lines of 3, 8 minus 2 times 3 plus 5 squared. Okay. Where do you start with something like that? Alright, there's a lot going on there. Alright, there's a lot of different things going on there, but essentially what it tells you to do is start with that bracket. Okay. Problem is we've got a multiple in that bracket, so we need to effectively restart our sort of thinking. So we've got 8 minus 2 times 3. Okay, so that 2 times 3 we need to start with and sort of tidy up. Okay, so we've got 3 bracket 6 plus 5 squared. Tidy up that bracket. 8 minus 6 is just 2 plus 5 squared. That bracket, if we take that away, is just 3 times 2, so that becomes 6 plus 5 squared. Okay, we do the square first just to tidy that up. So all that breaks down into 31. Okay, so just take it one step at a time, and we've done plenty of these now. We've broken out brackets, okay, we've done sort of indices in brackets and things like that. So there's loads of wee examples, but if you're ever unsure, just go back to the basic forms, okay? And I've told you that before. Often, just to put it in my head, just to make sure I'm okay with it, I'll do something really simple. Okay, I'll go back to the basics and I'll write out a simple equation, and I'll just do that in an order that I know makes sense. Okay, just take it one step at a time. So how do I apply that sort of BIDMAS in respect of swapping equations around? Okay, so we've got two equations. Arc times pi d we've been looking at, and we've been looking at sector. Okay. It can ask you to find any single one of those variables. Okay, it can ask you to find angles. Okay, it can ask you to find the radius, or it can ask you to find diameter. Okay, so let's go through, make sure we're comfortable with all the rules. How do we move this 360 over? Okay, how do we move pi over? How do we move either the radius or the angle over? Okay, and tidy up that square symbol. Okay, so make sure we're on top of that. Okay. So I'm going to go back right to basics and write out just a simple equation. Okay, an equation we all know. Simple as that. Okay, we know 2 plus 2 equals 4. Okay, that equal sign is really important. Okay, so if you imagine that as a seesaw, you've got the left hand side, you've got the right hand side. We want to keep that equation balanced. Okay, so whatever we do to this equation going forward, we want to keep each side the same so it stays level. Okay, so we can also write this equation if we want to move this over to the other side. Okay, we can write that out as 2 equals 4 minus 2. That equation still makes sense. Okay, and this is what I say, like, go back to basics, do something that's really simple that you know makes sense, write it out, go through it. Okay, that's the order it should be. A plus becomes a minus. Okay, how about when we do the multiples? Okay, with multiples, 4 times 3 equals 12. We know that. It's as simple as it comes. Okay, if we want to move this across, this 3 across, we need to move that 3 across, but it still needs to make sense. Okay. That still makes sense. That as an equation still makes sense. That left hand side still equals the right hand side. Okay. Likewise, okay, we could organize it so the 4 moves across. Okay, same thing applies. Because it's a multiple, it moves over to the other side, it becomes a divide. Okay, 2 really basic examples, and I'm sorry, I don't mean to treat it like that, but just really simple examples that looks at it. What are we doing there? We're changing the side, we're changing the sign. As simple as the rule comes. Okay, so what we do, some people teach it as what we do to one side, we do to the other. Okay, to keep that balance. That equal sign's all about the balance. Okay, one side has to equal that other side. So whatever we do to one side, we do to the other. Okay, so that change side, change sign is important. Okay, gets a wee bit trickier when we do indices, but we've been through indices and I feel we're quite comfortable with indices. But again, go back to basics and just write it out. Okay, if you've got an index, if you've got 3 squared, we know that equals 9. Okay, if we were to move that index to the other side, and we were going to change the subject to that formula just to the number 3, we know that becomes that. Okay, so when we're changing side, when we're doing a squared and we're taking that square to the other side, it becomes a root. Okay, now that makes sense. Now that's important for us when we do the r squared. So if we're changing the formula to r and we're having to organise it, we're going to have to take that squared sign over to the other side at one point. So we're going to have to take that squared and we're going to have to root everything on that other side. Okay, so if you get to the point you're like, oh, what do I do with that squared? Just write out something really simple. You know 3 squared is 9. You know 2 squared is 4. Okay, you know what happens when you move that square to the other side. Okay, cuts out, alleviates any issue. Okay, likewise, if you've got a root in one side, just do a simple one, 25. That root moves over to the other side, it just becomes a squared. Okay, so it works both ways. That equal sign is just that balance. We're wanting to keep that balance. Okay, so one side needs to equal the other. Okay, so why did I mention BIDMAS? What am I talking about reverse BIDMAS? Okay, so let's throw some more terms in there. Okay, if we've got something like 5 plus 2 times 2, we know that equals 9. Okay, so we want to make the subject of that. Okay, if we want to move everything over to the right hand side, just leave that term there. What order do we do that in? Okay, so that's essentially what the reverse BIDMAS is for. So if we write out BIDMAS here, when I say reverse, we're starting at the right side. So we're starting, are there any subtracts? Are there any additions? Are there any multiples, division, indices, brackets? And that's the order we are taking it over to the other side. Okay, and you can go either way. You can go right to left or left to right. This rule still applies. Okay, so long as that equal sign balances the two sides of it. So we want to make the subject of that equation that red circle, that 2. Okay, first thing I'm going to look at is there's an addition in there. Okay, so working from right to left, there's no subtraction, but there's an addition. Okay, so I'm going to move that over first. Okay, I'm going to move that plus 5, I'm going to move that over. So that becomes 2 times 2, change side, change sign, that just becomes 9 minus 5. Does that make sense? 2 times 2 equals 9 minus 5, 4 equals 4. Okay, so if we calculated that out, 4 equals 4, so that's right, so we're still on the same path, we're still doing things correctly. Okay, I'm still wanting to make the subject that. Okay, so what's the next thing I move over? It's just this multiply. Okay, so that's a multiplication, so that 2 comes over here. Change side, change sign. Okay, just leaves me with 2. 9 minus 5 over 2. Okay, 9 minus 5. 4. Sorry, 2. That works out. Okay, so if we did that calculation, that works out. Okay, so it's still balanced. Okay, so that's what I mean we're doing reverse BIDMAS. So we're starting subtraction, addition, multiplication, divide, in this brackets. The same rules applies. If we've got an addition and a subtraction on one side, then you can do either or. Okay, either or first. Okay, if we've got a divide and a multiply over one side and we're moving both of the terms over, we could do either or. And that's important for when we're moving pi and we're moving the 360. Okay, so when we come to do that will make a wee bit more sense. We can move them at different times. Okay, we can do the divide first or the multiply, it doesn't matter. Okay, as long as we do the addition subtraction first, then the divide multiply, then the indices, then the brackets. Okay, so let's do a wee bit more complicated. Let's throw in a bracket in there, but let's do an equation we can work out with the numbers. Okay, so if we've got 6 plus 3 bracket 4 minus 2, that equals 12. Okay, so if you did that calculation, 3 times 2 is 6, so 6 plus 6 is 12. So left hand side equals the right hand side. So that's balanced. Okay, so we've got balance right now. So we want to start moving numbers across, and we want to leave on the left hand side just the number 4. So we want to move everything else in that equation over to the right hand side, okay, and just leave on the left hand side that number 4. Okay, let's write out our BIDMAS again, and then just start working through it. Okay, first thing we're looking at, is there an addition or subtraction? Yes. Okay, so that's going to be the first step. Okay, so we're going to move. We're going to move this over. Okay, and we're going to just leave that multiplication. So we're going to move that over, and we'll leave ourselves with 3, 4 minus 2, 12 minus 6. Okay, change side, change sign. That positive 6 becomes negative 6 on the other side. If you work through that calculation, 6 equals 6. Okay, we're still balanced. We're still balanced. Okay, next, there's no more additions or subtractions that are out with a bracket. Okay, so importantly, that bracket's still there. That's got a subtraction in it, so we need to deal with that eventually. But because that bracket's there, we deal with the bracket at the end. Okay, so now we look at the divide and multiply thing. Okay, we're going to divide and multiply. Yes, that 3 is effectively 3 times whatever's in that bracket. Okay, so that 3 is a multiplication. So that 3 is coming across. Okay, so we move that 3 across and leave ourselves 4 minus 2 on one side, 12 minus 6 over 3. Another. Okay, and you can work that out if you want, but the left hand side should equal the right hand side. Now, at this stage, where did the bracket disappear to? Okay, as soon as I move that multiple across, that bracket's not needed. Okay, all that bracket's doing is holding that form 2 is one function. Okay, that 3 multiplies that whole bracket. So as soon as I took that 3 away from the left hand side, you can leave that bracket if you want. Okay, but it doesn't mean anything mathematically. It's still there. Okay, still all that is effectively just 1 times that. Okay, we don't need to write it. It doesn't tell us anything. Okay, so that means the same thing. Okay, so left with that. Okay, we're trying to find the 4, remember? Okay, so we're left with a simple addition on that left hand side. Okay, that's odd because it seems like we're going backwards. Okay, but that's because we had to deal with a bracket. Okay, so we had to deal with tidying up this bracket. We had to break that bracket down and work with everything around it. So essentially we had to tidy up everything around that bracket before we actually deal with inside that bracket. Okay, now we're inside that bracket, we essentially have to start back at the beginning. So whatever's inside that, if there was a multiplication, if there was an add, whatever's inside that we need to deal with. Okay, so you could write out BIDMAS again or just realise we just need to take the 2 away. Okay, so that negative 2 comes across. Okay, so importantly here, okay, that negative 2 doesn't get added to that top line. Okay, if you worked all that out, okay, at 12 minus 6 over 3, so that would be 2. Okay, we have to take away the 2 from that whole term. Okay, now that's just a wee bit awkward and it looks a wee bit messy. Okay, but when we do it in real life, it actually makes a wee bit more sense because you wouldn't leave. You would tidy this up as we went along. All right, so you wouldn't leave that sitting like that. You know what I mean? You would figure that out. Okay, and you would just write 6. Okay. You know what? I'm just going to do that. So as I go along, I'll just tidy it up. Okay, and it will make more sense to you. So essentially that's just 3, 4 minus 2 equals 6. Okay, then we're going to move that 3 across. So 4 minus 2 equals 6 over 3. Okay, which is 4 minus 2 equals 2. Okay. And 4 equals 2 plus 2. Okay, so 4 equals 3. Okay, so you would tidy it up as you went along, so you wouldn't leave it like that, it wouldn't be as messy as that. Okay, what we had written out there. Okay, but essentially the left and right hand side need to match, need to balance out. Okay, as we go along. Okay. Let's throw a wee square in there, then we'll throw in a couple of letters, and then we'll do our arc and sector examples. And then we'll call it a night. Okay, so does that make sense? I hope I didn't confuse you there by sort of tidying that up. Okay, if it does, take it away, digest it, and come back to it. It should be a nice simple example. Okay, didn't want to try and confuse you there. Okay, so another example. Let's throw a squared in there. The numbers that we know are right. Okay, so 3 squared minus 5 equals 4. So left hand side equals the right hand side of that equation. Okay, we want to leave on the left hand side just the number 3. Okay, we're going to do it by doing reverse BIDMAS. Okay, first thing we're looking for, can we move any add or subtract over? Yep, we can move this minus 5 over to that other side. Okay, that leaves us with 3 squared on the left hand side, 4 plus 5. Okay, so if we were to tidy that up, it would be 3 squared equals 9. Okay. Okay, 3 squared equals 9. So we're correct. We're on the right path. We know what we're doing. Okay, now we're left with the squared on the left hand side. We want to get that square away, so we're just left with 3. So we know that's 9. 3 equals 3. Okay, so we've stayed balanced all the way down. So everything on the right hand side has always been what we've said on the left. Okay, so nice simple example. Sorry, I never indicated what that was there. Okay. So there's no divide and multiply in this, so there's nothing to divide and multiply to take across. Okay, we've gone straight to indus, taking that indus across. Okay, let's just make sure we're comfortable with when we've got an indus in a bracket. Okay, 3 plus 2. I'd say this is going to be the last example. Okay, so that works out. So if you calculated everything on the left hand side, it would equal the right hand side. That equals is just a balance. Okay, what do we want to leave here? Let's leave the 3. Okay, so we want to move everything over to the right hand side and leaving the 3. Okay, again, we're going to reverse BIDMAS. Is there any add and subtract? Yep. Okay, so we move that first. We're left with 3 plus 2 squared, 29 minus 4. Okay, so 3 plus 2 squared equals 25. Okay, we're looking at leave the 3, remember? So we want to start removing everything from around that bracket. Okay, so if the next part is there any divide or multiply, the answer is no. Okay, there's nothing dividing or multiplying on that left hand side. There is an indus. Okay, so that will be the second part we move across. We want to move that indus across. Okay, as soon as we leave that indus, we don't need the bracket on the left hand side anymore. That becomes root 25. Okay, so change side, change sign. Okay, so we're still balanced on each side. Then we're left with what's inside the bracket. Okay, similar to what we've done before. Take that 2 across, and it leaves us with that 3. Okay. Right. So remember that symbol pi, that's effectively just a letter. Okay, so remember when we've been working with algebra with the x's and stuff, we can collect like terms and things like that, and we can move that x about. And the same rules apply. So once we change side, we change sign. Okay, so let's throw an x in. Okay, just to make sure that we're comfortable with that. So we've got x plus 4 equals 7. Okay, we could also write that as x equals 7 minus 4. Okay, change side, sign, change sign. Okay, or we could write that as 4 7 minus x. Okay, so we can write that equation in 3 different ways. That all says the same thing. Okay, so that's probably the most important thing. That is always balanced. So every single one of those equations is always balanced. Okay. Likewise, if we've got 4x equals 8, okay, we can say x is equal to 8 over 4, or we could say 4 is equal to 8 over x. Okay, so that's just the same way as writing out that same equation. Okay, so don't be put off by letters and symbols. Okay, pi is just a letter. Pi is just a Greek letter. Okay, mathematicians, engineers love Greek letters. Okay, why? Yeah, because they're pretty good at it. All right, so they came up with it. I suppose they can use their own letters. All right. Let's think of the x's squared. Okay, so if we've got 3, in fact, I'll use a different letter. Let's say s squared plus 5 equals 17. Okay, we want to leave s on the left-hand side. Okay, we work through that same BIDMAS process. So you don't mind if you, in the exam, if you write BIDMAS and you actually just methodically go through it. Is there any add and subtract? Is there any multiply, divide? Is there index? That's how I deal with it. Okay, write it out and go through that process. Okay, I know first thing I'll move across is that 5, 17 minus 5. Okay, so 3s squared. I can write that as equals to 12. Okay, that's the same. S squared, 12 over 3. So s squared, I can write as 4. S would be root 4. S would equal 2. Okay, all the way through that, the left and right are balanced. Okay, so
Daniel, what type, if this was in an exam, what type of question would it ask you?
So there is actually a question where you actually rearrange equations. Well, we do it later on, so I'm only doing simple ones right now to allow us to rearrange the arc and sector question. So don't do these rearranging questions yet. There's a few more bits, more tricks to learn. Okay, I'm just giving us enough information to allow us to rearrange the arc and sector, just in case you see that coming up. If you're if it comes up in that booklet, or if it comes up in the handouts, I think 1 or 2 of the questions in the handouts I gave a couple of weeks ago has rearranged to find angle or rearranged to find diameter. Okay, so I've just given you enough to do that. Okay, but it's a good place to start, and we'll jump on it in a month or so time when we look at it in detail. Okay, So don't do these specific questions yet. Just use it to allow you to do the arc rearranging.
Thank you.
Okay. Reasonable question. Okay, so let's look at that then. Let's write out and let's rearrange using that reverse BIDMAS idea. Okay, we've got arc is equal to the angle divided by 360 multiplied by pi multiplied by diameter. Okay, let's write BIDMAS beside that. Okay, and let's rearrange that equation to find out that angle. Okay, now this is where the fact that you can move, divide and multiples over in whatever way suits becomes relevant to us. Okay, so we can move this first, or that. Okay, it doesn't matter. We can move the divide or the multiple in any order we want. Okay, but just do it one at a time. Okay, so arc equals, okay, multiplied by pi. Let's move the divide over first. Okay, yeah, the diameter, sorry, my God. And it becomes a divide. That's what confused me there. Okay, everyone comfortable with that step? So we've taken the diameter, we've just taken it across, it becomes a divide. Okay, same thing with pi. And same thing with the 360. So the 360 becomes a multiple on the other side. So it becomes arc multiplied by 360 over diameter times pi. That will leave us with angle. Okay, I'm sorry running out of time tonight, so I'm not going to do examples of each. I'm just going to leave you with that. Now, try, even if you go back to a question you've already done tonight, remove the angle from it and try and find that angle from that information. Okay, so if you've worked out the arc length, take that arc length and substitute that in, if you know what I mean, and work out the angle from it. It should work out, well, it will work out to the same. Okay, so just make sure that makes sense. Just before we go, I'll do it so we can look at r squared. Okay, so we've got our other equation, which is area equals angle over 360 multiplied by pi multiplied by r squared. Okay, if the question asks you find r, okay, you need to move all of this and this over. Okay, the wee bit of the complication here is when we move the squared part. Okay, so that's when the BIDMAS is important, the reverse BIDMAS. So we're always working backwards. So we need to always move the multiply and divides before we move that squared. Okay, so the squared doesn't move until everything else, if we've got an addition, if we've got a multiply, if we've got a divide, that all has to go before that squared moves a centimetre. Okay, so the area multiplied by 360 over the angle times pi equals r squared. Okay, jumped a wee bit there, just for timing reasons. Okay, and then r left, and you'd need to root everything in that. Now remember, when you're writing out this question, you'd solve that. So you'd have that number solved. Say area times 360 divided by angle times pi. and that left you with 25. Okay, you just put root 25 in there. You wouldn't put a root over all that, but essentially what we're doing is putting that whole equation and rooting it. Okay, that will make more sense when there's numbers involved. Okay, so don't look at that and go, what the, that looks messy. Okay, but when there's numbers involved, you can tidy up those numbers. So you can do the multiplication or you can do the divide, and you'll just be left with a whole number. Bring that over and just root that whole number. Okay, so it will make more sense when there's numbers involved, but essentially that's what you're doing. Okay, again, some of the questions you've tried before, take out the radius, okay, and then work everything out and try and find that radius, okay, and just make sure that it matches. Okay, super. Okay, that takes us right up to 5 to 9, so whoa, that's like, it wasn't too bad. Okay, so any questions before we stop then?
Will you go